All right. Now, this question is actually based on, so this is a cubic function, right? You've heard this term before, cubic equation. So quadratics, okay. So we've got, the naming is this. Linear is like ax plus b. All right, that's a linear equation, yeah? Because the power of x is 1. Right, have you heard of this?
Yeah,
Linear?
but our school right says mx plus c.
Oh, yeah. So mx plus c, okay, I'll use the same notation, mx plus c, yep. And then quadratics, right? A quadratics equation is when the power is squared. So that would be ax squared plus bx plus c. There are more than one form, but I'll just use this form for now. This is called the standard form for quadratics equation. And then there's cubic equation, which is the ax cubed plus bx squared plus cx plus d.
Oh, so that's actually in like a form already?
Yeah. It's already in that form, yes. Oh. Okay, so this is already in like one of the forms of the main expanded form for cubic equations.
Oh, so once we learn that, would this become like a CE level question?
You mean once you learn that one?
Yeah, that one.
Then that one will become a what?
C level question?
C level?
Very easy?
Yeah, well, I wouldn't say it will be very easy. It will be a little bit easier. Yeah. But I guess, yeah, it will be easier. Because this technically in Unit 1 Math Methods, you will learn something called, the technique is called polynomial factorization. Okay, I'll break it down. Factorization is turning something like this into like a bunch of brackets multiplied together. Okay, that's what factorization is, right? And polynomial is just a name for all of these. All of these things are called polynomials. Okay, so polynomials are expressions. So formally, it's written as it's ax power n times, or ax power 1, or actually at times n, and then plus bx power n minus 1 plus ... plus c plus a certain constant c.
So it has to be in that format?
Yeah, it has to be in that form. Well, doesn't have to be in this format, but a polynomial p of x is defined as anything in that is somewhat in that format. Okay. There are different versions of the quadratics, which is the turning point form. Have you heard of it?
Sorry?
The turning point form.
Oh yeah, I think we did that in specialist. It's what?
Yeah.
It's a minus thing and then a plus something.
Correct.
I think I did it.
Correct.
I can't remember.
Yeah, so the turning point form for quadratics, right? There's another version here, which is the a times x minus h squared plus k.
Yeah, we did that.
Yeah, so that's the turning point form.
It's exactly like that.
Yep.
And our teacher told us a method to turn, like the quadratics into that, and then we can actually solve it. Solve the actual quadratics. We can factorize that. Which is like, I think you divide b by 2 and then square it. I think something like that.
Yeah, it's called completing the square.
Oh yeah, completing the square.
Yep. Are you familiar with that?
Yeah, but I don't think I can remember.
Okay. When it comes up again, we'll go through it. Okay. Ask me if you need any help on that one. But for now, I'll do this one, which is polynomial factorization. Now the idea is this: if you so actually this is based on the factor theorem. So what's a factor theorem? So let's say that if we can find a value, so let's say that px, the polynomial, is equals to, let's say, x minus some value a, right? Let's say it is factorizable, so it will be x minus some sort of value a, and then times by some other thing. Okay? So assume that px is factorizable. Yeah, does it make sense so far? Yeah. Factorizable, yeah. Then does it make sense that p of a must be 0? Does it make sense? Okay, I'll leave this one here for a second. What does it mean? Let's say when you substitute x equals a, right, into this equation here, right? And this is the same as p of a, right?
Oh, yeah.
Oh, wait. Have you learned this notation yet? P of x? No. Okay. This is function notation. Okay. So p of x means a polynomial of x. So for example, right? Let's say p of x, a polynomial could be just a very basic linear one. Okay. And then let's say p of 3 means that It just means that p-value when x is equals 3, right? When you sub x equals 3, then it will be 2 times 3 plus 1. That's it. Which is, so p of 3 would be 7, right? And then p of 4 would just be 2 times 4 plus 1, which is 9, right? So p4 is 9. Yeah, so p of a just means it's 2 times a plus 1, whatever a is. Make sense? Just instead of x, you put a, right? So now, when you substitute x is equals to a, so this is the notation for the function notation. So when you sub x equals to a, you see how p of x would be, so that would be p of a, right? Then that would be a minus a, and then times by another bracket, which must be 0, because a minus a is equals to 0. And 0 times anything is 0. That makes sense? Yeah. So the factor theorem actually says something that if when you sub x equals a into p, aka when you sub x equals into p, the answer is 0, right? The answer equals to 0. In other words, p of a is equals to 0, right? If that's the case, then x minus a is a factor.
Is it 100% 0?
If it's equals to 0, then it will be a factor. So for example, right? Let's say if we have a polynomial of x, so for example, okay? If a polynomial of x is, let's say, x squared plus 3x plus 2, okay? Let's say I substitute x equals to -1. Alright, let's see, when you sub x equals to -1, then p of -1 would be -1 squared plus 3 times -1 plus 2, which is 1 minus 3 plus 2, which is 0. So what does this factor theorem say? The factor theorem says that therefore x minus that number, so x minus -1 is a factor. Is a factor. What does it mean if it is a factor? If x minus 1, which is x plus 1, yeah, so simplified to x plus 1, is a factor, it means that the polynomial x squared plus 3x plus 2 must be factorizable into x plus 1 times by something else.
Is it always x plus 1 or is...
No, it's only because we substitute x equals to -1.
So if you substitute it in -2, would it still work?
It will still work, yes. So let's say if you substitute, I think I see why you see it. That's good. But yeah, let's say if you substitute -2 in here, right? So we'll redo these steps here. All right, so that'll be 4 minus 6 plus 2, which is 0. Then yes, my x minus -2 or x plus 2 is a factor. And because x plus 1 is a factor and x plus 2 is a factor, then it must be in this case here.
What content is this?
This is the math methods content, factor theorem. Okay, so the name of this technique is called the factor theorem. All right. Again, I will go back to the idea behind this. The idea is that if, right, p of x is equals to some sort of x minus a times by another bracket, then p of a must be equals to 0. Make sense? Right? Because when you get a into x, it's just a minus a, which is 0. Yeah. So the factor theorem says the opposite, right? The factor theorem actually says the opposite. So if you can find a value of a where you get p of a is equals to 0, then you can actually say that p of x must be equals to x times a times by another bracket.
Does a have to be positive?
No, it could be negative. See, the answer here is negative. So minus 2 is plus 2. Right? Does it make sense? Okay, I'll show you another example. All right. So again, this is the factor theorem here. Yeah. I'll leave the space here because I'll go back to this question later. It needs a bit of space. Okay. Another example is, let's say the polynomial would be x squared minus, let's make it something, 4x plus 4. All right. Find a number that when I sub that number in, I would get 0. What do you think?
It becomes 0? 0.
Yeah, so find the number for x. So sub x equals something. That the answer would be 0. Hint, it's normally not that high. It's normally like one of the smaller numbers. Okay, in this case, the answer is 2. Let's see. Okay, actually, I'll show you a non-answer first. If you sub 1, right, that would be 1 squared minus 4 plus 4, which is what? 1. Right, so that's not right. Yeah, now we'll try another one. We'll try 2. Normally, you try the basic ones, which is like 1, negative 1, 2, negative 2. Right, these are the basic 4 that you normally have to try. Most of the time, the question will be in this form because normally it's like when you learn something, it's like simple formula. Right, SF, they will give you easy stuff. So P of 2 would be 2 squared minus 8 plus 4, right? So that's 4 minus 8 plus 4, right? That's 0.
Do you have to test out the number or?
You have to test it out to make sure that it equals to 0. See, just now we test 1 and it's not 0. Right? If you test 2, it is 0. Which means that using the, so therefore, by the factor theorem, right? By the factor theorem, x minus 2 is a factor of px. So why do we try to find a factor of px? Well, the idea is that if you find something as a factor, you can take this and divide by that to find the other factor, right? It's like saying, okay, 2 is a factor of 98, for example, right? So you would actually go 98 divided by 2 to find the other factor, which is going to be 49. So then you can write 98 as 2 times 49. So you write it as a product of two factors. Okay? So this is the same idea. This is the same idea with the polynomial here. But instead of doing that, so you would go P of x divide by x minus 2. Right? X minus 2 would be equals to the other factor. Right? This is not mathematically correct, but does it make sense? Yeah. So now we need to actually do division. So the division would look something like this. This is the one that I think you're a little bit confused about.
Oh, so that's how you get. Oh, that's why my teacher told me to test out a number that's make the equation equal to 0.
Yeah. The factor theorem. Yeah, it's just telling you what to do without giving you why you have to do it. But I'm telling you that.
How do you divide that?
Good question. So you take the leading number. So the idea is that when you're dividing polynomials, right? You want the number on the top here. That when you times into this, you get some answer here, and when you do the subtraction, you cancel off the x squared. Does it make sense? So you simplify the polynomial one by one. Yeah, it's similar to that, right? Don't worry about it. I'll get to that in a second.
So that's why it's 0, 0, 0.
Yep, that's right. Okay, so the technique is this. You can go back and actually try these questions. So the technique is you take the leading term. So the leading term is the term with the highest power, basically the first one, right? You take x squared, you divide by x, because you want something that when you multiply into this, you get x squared here.
You divide by x, not x minus 2.
No, you divide by x only. Okay, I'll show you what it means. So first you take this divide by x to get the number on top. That would just be x, right?
Oh yeah.
Yeah. And remember how when you want to get the number down here, you need to take this times that, right?
Oh.
But what you're actually doing is this. So you're actually doing x times x minus x times 2, right? Whatever the stuff on top, you need to times to each of the terms in here, right? So then you would get x squared minus 2x. Does it make sense?
Yeah.
And then similar to a normal division, you need to subtract this from the top. Right, so you subtract it, that would cancel out, right? That would just be 0, right? I normally just don't write anything because it would be 0. And then minus 4 minus minus 2 is minus 4 plus 2, that's negative 2x, right? And then you drop the plus 4 here, right? Yeah, same thing again. You take this one, divide by that. What would be the result? So that I will get negative 2x. The answer is negative 2. Right, and then once again, you're taking negative 2 times into the whole x minus 2, so that'll be negative 2 times x.
So that's all.
Sorry?
I said that's all.
Yeah, that's all, yeah. And that'll be plus 4. And then when you subtract that, you would get 0. It's the same as a normal division. But you see, once you use a factor theorem, the remainder it must be 0.
Can I try that question myself?
Yeah, try that. I'll leave this one here, try that yourself.
That one?
This one?
Yeah,
The main one?
yeah, the main one.
Okay, yes, you can try this one out. So first, let's say this is a polynomial px.
Yeah, oh.
You got
the same thing, but just one more step.
Yes.
This is the first time I used this book. The first time I remember to read it.
Okay.
I should put my jumper in the last class.
If you want, I can send you more of these factor theorem questions for you to try.
Yeah.
Okay, I'll make a note here. It's actually for math methods, but I can send you more because you have to learn it next year.
Will we be using this in specialist?
Yes, you will be. In the first few units. I think later on you won't need to.
So
It's more for methods.
for this one, it would be x squared, right?
Yeah, x
And then
yes.
what are right? Is it just here?
Yeah, on the top, yeah.
Okay.
I'll write the first bit here as well, yeah? The whole thing with the factor theorem here, so you can see how it's actually going to be written.
Oh, so that's different.
Oh, good. Yes, that's basically it. Fast. I was going to show you the answer, but yeah, I think you get the idea. Okay, good. Any question?
No.
No.
Is this like the hardest level, or it can still get harder?
It's basically the hardest level for factor theorem. The harder one would just be if the power here is like x power 4. But same technique,
yes.
you find a number, you send that equals to 0, and then you divide.
Okay.
That's it.
Will that always be like around 1 and 2?
Normally, yes. The worst you will get is like 3 or -3.
Oh.
I think that's the worst you will get.
Okay.
Because if it's like power 3, you get 3 cubed, which is like 27. And some student, they're like, what's 3 cubed? So, yeah. So yeah, I don't think you get anything worse than -3 and 3. Okay.
Can I get this on like graphic calculator?
This one?
Yeah.
Most likely no. You get harder than this. But because in the graphics calculator, you don't need to do this by hand.
Oh, we done?
Yeah. If you have the calculator, okay, calculator technique is something completely different. You should get that soon. I'll teach you a few calculator techniques.
Okay.
Alright, but when you have a calculator, you don't solve anything by hand.
Oh,
The
just
idea
type it
is
in.
You type it in, but you need to know what to do when you have the calculator.
Yeah.
Okay.
So confused.
Yeah, you should get the graphics calculator soon.
Yeah, I'll tell my dad to get it.
Yeah. Okay. What was that? All right. So that was basically the content that you needed to go through, right? And you're doing matrices at school. Yeah.
I don't know why, but we're still doing content while we're doing the assignment.
Yeah, that's normal.
Oh, it's normal?
Yeah, it's normal. Because the assignment you're supposed to go through by yourself,
Oh.
technically. Yeah. Yeah, that's why. It's going to be a bit hard, but that's okay. I'll go through this one here, the task sheet. Actually not. I think that this assignment is quite easy. It's going to be easy for you. That's why what I want to go through is that sheet there, which is the technique to how to write assignment. I will send you 2 examples assignment. You may not understand the mathematics because it's year 11, okay? But it's 20 out of 20.
Oh.
Like there's nothing else I would recommend. Well, there are a few minor things I recommend, but basically the assignment is mint. All right, 20 out of 20. And that guy, I'm actually teaching him at the moment. He's in year 12. He's finishing specialist math. Yeah, so he's doing also methods and specialist in year 11. Anyway, okay, so let's go through this assignment here. Basically, you just need to ignore everything. This is the main thing in your task. Okay, this is the main thing here. So you need to test a claim made by an organization or company using hypothesis testing. Right, and then you can choose a topic and claim yourself, but you need to check with your teacher to make sure this is unique and will be viable. You must research sampling of at least 20 values and use inferential statistics. Okay, before I tell you anything about this, what do you think? Does it make sense, the task sheet?
Does it have to be a real
Yes.
claim?
Yes. I can think of some examples. I'm not sure if your teacher will accept, so you have to wait until the teacher talks about the assignment first. But I can think of so many examples for you to do. What are they claiming here?
What is it? What claim?
Yeah, what are they claiming? If they, what claim are they making with this bar here that we can use hypothesis testing on?
Oh, the what is it called? The weight?
The weight. Do you think it's going to be exactly 43 grams? No.
No. If
Do you want it? You can have it.
No, it's fine.
Right? It's not going to be 43 grams.
It's probably gonna be like 43 point something.
Correct. Or 42 point something.
Oh.
Right? Again, remember, normal distribution.
Yeah.
It will vary. Right? It will never be exactly 43. The chance of a bar being exactly 43.0000 is
0.
0. There's no way. Right? There's no way you can get something exactly 43 grams. So that's why you have to do hypothesis testing. So something as simple as choose your favorite food, because you need to measure quite a lot of it. Okay? So let's say this Bao Bueno, they claim to be 43 grams. You need to do sampling of 20 values. So you buy 20 of these bars.
Do I have to buy it or I search it up online?
I mean, you have to actually do your own research.
Oh.
Yeah, you have to do your own research. But remember, the idea about sampling is you need to sample. Okay, normally, right? Normally, when you're sampling, you need to sample in a way that every single one of them has an equal chance of being selected of a batch, right? But okay, maybe I'll talk about this. Actually, no, I'll mention this. Okay, put it this way. I bought this one in the Woolworths near here, which is the 8 Mile Plains one. Okay, do you think the chance? Okay, if I only go to that Woolworths and get 20 of these bars, is it going to be a good representation of all Kinder Bueno?
Oh,
like
so
in
you're
the
saying
world?
that I have to go to like Woolworths all around Brisbane?
Ideally, yes. If you're testing the population of Kinder Bueno in Brisbane.
Oh.
Because if you only go in Brisbane, you can't make a claim for Kinder Bueno in Melbourne. Right? Because they may be produced by a different factory. And each factory may be a little bit different.
I mean, I can just buy it at one Woolworths and then say I put it at like multiple stores. Right?
No, you don't. You don't need to. You don't need to. Okay. The thing about the assignment is that you don't need to have a perfect assignment, and you cannot get a perfect assignment because you're a student.
Oh.
You cannot get a perfect assignment. Okay. Your sampling methods, whatever method that you use, will not be ideal. And the key is realizing that it is not ideal and talk about why it is not ideal.
Oh, so that's why it has like those limitations and improvements.
Yes, that's the one. Okay, your assignment is not supposed to be perfect.
Okay.
Right, and it's okay as long as you know why it's not perfect, and then you talk about why it's not perfect. That's how you get a mark.
So basically, you just do a not perfect on purpose.
Not on purpose. You do your best. Okay, you still have to do your best, right? Because you need to show that you have actually done a lot of work in your assignment, but still realize that this is the maximum capacity, right? Put it this way. Let's say, like even a real researcher, right? A real researcher, when they're researching, for example, like cancer treatment, right? They can't possibly test on every single population, right? They may, if they live in Canada, they might be able to test like within a certain population in Canada, and they have to make an assumption that okay, this will work for people in India, but you don't know, right? So they have to do that research on those people in Canada, and then make at the end they still have limitation. Like real researchers, they have limitations too. They're gonna say that oh, this is only in a small population in Canada, in this time Quebec, Canada, and it needs to be tested in other parts of the world. Even real researchers, they have limitations. So you are a student, definitely you have limitations. So look, you can always just go to, yes, you can claim that you bought it from different stores because there's something called the batch number.
So I actually have to like go to every Woolworths. I can't just buy that one and then say it's for it.
Yeah, because if you buy it and then it has the same batch number, it's like that's the same batch. You can only test for that one batch. Does that make sense?
Yeah.
So if you get it from different batches, then you can claim, well, this is because it's from different batches, it represents like a wider population of whatever Bueno.
So it's just a claim made by an organization or.
Yeah. So it could be okay. This is my assumption of this assignment. A claim is basically what they claim to be on here.
Oh, so it can even be like how many calories it has.
Yeah. But how can you test calories? You know what I mean?
Yeah.
Yeah. So it can be literally be anything. Like if it's a can of drink, right? So for example, I have some cans of drink here. If it is a how to get it okay. The reason why I took out the bar first is because this can of drink, right? The claim is in milliliters. 250 milliliters.
Oh, so that what is it? 1, 2. Oh, so it'd be 0.25, and it's more accurate.
0.25 liters. Yeah. Oh, you can just use milliliter. Doesn't matter.
Oh, okay.
Right. So yeah. So you would so 250 milliliters. But in order to test this, you need to pour that into most likely a measuring cylinder that has a graduation of like 0.01.
Oh yeah.
That's hard. If you get this, you chuck it on a kitchen scale. The denomination is like 0.01. You need to find something.
Does this count like the can in or just?
No, I don't think so. I think this is net weight. Similar to this one, should be net weight. Yeah, because it said here 2 bars inside, 21.5 grams each.
Okay.
So technically, you can test that claim 21.5 grams each. So you buy one of this and then you get 2 bars. Right? Yeah. So yeah, you can actually technically even test that one. That should be okay too.
I think I have like a general idea of how to do this assignment.
So just wait until your teacher says about this. But you can actually start writing. Can you start writing? No, you have to wait until you decide on what is it you're testing, and no, you can start writing. I'll show you what you can start writing with. But okay, does it make sense?
Yeah.
Now get 20 of something. At least 20. You should get more than it if you can. Choose something cheap so you can get 30 or 40. You actually need to do the experiment. Yeah.
Is it possible if I test like 1 grain of rice?
But they don't claim grains of rice.
Okay.
They claim bags of rice.
Or 20 bags of rice. That's too much.
Yeah, no. That's what I'm saying. You know how much is this? This is $1. So if you buy 30 of this, it's $30. Or if this is like 2 bars in here. If you can claim like the 2 bars thing, one of this is $1 for 2 bars. So if you want 30 bars, you buy 15 of these. $15.
What's the word limit for this?
1,000.
Only 1,000.
Oh, sorry, 2,000. 2,000 words. Yeah, 10 pages, 2,000 words. I'll get to that in a second. Okay, but okay. So basically, you need to do 2 things: hypothesis testing to justify whether the hypothesis is supported. So remember, the hypothesis is always the claim, the basic one, like no change. Which is, if it's this case, it will be the hypothesis is the mean is equal to 43 grams. So it'll be 2-tailed, right? 2-tailed test.
So can I talk about like how many percentage of this product has a lower weight than this?
No, because that's not hypothesis testing. Remember, hypothesis testing is you can calculate it, but it doesn't really mean much in this assignment.
Well, that would be normal distribution, right?
You should you can assume that it's normally distributed. Or remember, the idea is that have you learned central limit theorem at school?
I don't think so.
Wait, what? Hang on. Central limit theorem.
Can you like write it out? I don't think I've heard of that name before.
I'll send you this note as well, but central limit, I'll write it better, limit theorem. Oh, maybe you haven't learned this one yet. This one is technically year 12 content. Okay, so the central limit theorem said that if the sample size is large enough, so normally more than 30, you need to find the source for this and quote it. Okay, if the sample size is at least 30, then the sample mean will follow a normal distribution.
Oh.
Okay, so yeah, that's the idea for the central limit theorem. If the sample size is large enough, at least 30, that's why I don't know why they said 20 values. That's probably because some students, if you do 20 values, they can't talk about central limit theorem and they have less marks. So most likely you need to talk about central limit theorem. I think your teacher may not mention about this theorem to see who actually will do research and know about this. So I'm already giving you half of the answer. Okay? Because this is actually year 12 specialist central limit theorem. This is unit 4 in year 12 specialist.
So if you don't say that, then it's basically like not normal distribution, so you can't do it anymore.
Well, put it this way, an assignment cannot mention the central limit theorem. Use only, they will not, like, okay, let's say an assignment, right? Let's say if you don't use the central limit theorem and you only use 20 values, then you have to make the assumption at the beginning. You have to write the assumption that the sample mean will follow normal distribution. You have to explicitly say the assumption.
Oh, but if I say this, then would it be like, what is it? Observation?
Yes, it will be observation, but be careful. The central limit theorem is year 12 content. Okay, you're not supposed to know about year 12 content. So just mention briefly to your teacher that like, oh yeah, I saw this thing online. When I tried to watch a statistic video, they mentioned central limit theorem. Like, do I have to use this? Most likely, your teacher will say no.
No.
Because your teacher wants you to write the normal distribution, as an assumption instead.
I mean, my teacher can't even teach.
Yeah, no. Go to the head of math. Yeah. I mean, teacher is the head of math, not the unreliable one. Yeah, so you go to the head of math and ask about central limit theorem. Okay, if you can't use it, that's okay. You just have to make the assumption explicitly. Okay. So there are many ways around an assignment. As long as you can show you've done a lot of work, it sounds mathematically smart, you get a good mark. You don't need to do everything.
But if I include it in the limitation, and can I just say next time I would do like probably 30 values to make it like that, to make it in
you can, yeah.
Okay.
Oh, you can, yeah. Yeah, that should be okay. All right, so that's a hypothesis testing version, and then you need a confidence interval as well. So the math behind these two techniques are what will give your assignment, like the mathematics of your assignment.
Why would we need confidence interval?
Just to say, you have to make a statement that what you believe the population mean is.
Or what I believe it is.
Yeah.
So I will it has like two values, so I add up them and then divide it by 2. That's what I.
No. No, because the confidence interval always centers around the sample mean, right? So if you have them, then it's just basically you're saying the sample mean is the population mean. No. You just make the statement about the confidence interval, right? You'll be like, it's like the answer to the confidence interval question. It's like, based on this sample, the 95% confidence interval for the population mean is this.
So that's it's trying to say that out of 20 level chocolate bars, 95% of them is.
No, you said exactly what I just said. You can't change it because that's the meaning of the confidence interval. The confidence interval is like two numbers, right? A and B, right? Right. So you have to say 95% confidence interval for the sample for the population mean. For population mean is this, and that's it. You can't make any other one because if you say anything else, it's actually wrong interpretation. Remember, the confidence interval, or like a 95% confidence interval, is the idea that when you have 100 of these intervals, then 95 of them will contain the mean. Which 95, we don't know.
Oh, so that's why you like drew those things. Oh.
Yeah, this thing, right? Yeah, so there'll be 95, like even if you do like 95 of these, right, there'll be 95 of these intervals. But which 95 contain the mean, we don't know. So we don't know where the population mean is. That's why be very careful in the assignment. You can't say where the population mean is. You can only say, okay, this is based on this sample, the 95% confidence interval for the population mean is these values here.
Okay, that's all.
That's it. You know, it's and then earlier on you would talk about what is a 95% confidence interval, right?
Yeah.
Okay. Does it make sense so far?
Yeah.
So that's what you have to do. Now let me get to the actual notes that I've prepared there. Let me go through it and explain a little bit more in details.
What is PSMT?
Oh, problem solving and mathematical modeling. Mathematical modeling task. Yes. Oh, problem solving and modeling task.
Oh.
Yeah, that's the name for your assignment. What was that? Okay, I need to go to Google Drive.
Where's the year 11 matrices? I saw year 11 matrices. Week in Google Chrome.
Oh yeah, you have no matrices?
It says week 5 content and year 11 matrices.
Oh yeah, that was the plan for today until you showed me your assignment. And that's I'm like, no, we have to go through the assignment first. Because matrices, you can always learn that later. Yeah. Next week we can learn next week content and then even jump a little bit ahead. But I want to go through that assignment because the thing is, the very first piece of assessment for methods and specialists is an assignment. The one that counts towards data is 20%. Is the assignment.
So one term only the assignment, no exams.
Yes. Yeah.
Oh, okay.
I think that's term 4 in year 11.
Oh.
Yeah, term 4 in year 11. For methods, I'm not sure about specialists. Every school is a little different. Okay. The unit 3, the first piece of assessment is an assignment.
Why do they let us do assignment and exams at the same time? Why can't we just do like one at a time?
I think it's one at a time.
Is it?
Yeah.
Or,
so term 4, year 11 will be assignment for methods, and normally term 1 in year 12 is the unit 3 exam.
but right now we're doing this and then also the exam.
Also the exam?
Yeah.
Because you're in year 10.
Oh.
They're just cramming it in. Yeah, but year 11, you normally don't get the assignment that count towards data and the exam in the same time now. They're just cramming it in so you get more experiences, that's all. Okay? So that one, and then...
Wait, have you learned about Lewis dot structure? For
the
chemistry?
Lewis dot structure?
Yeah.
Yes, I have.
I don't think you should explain it really well.
Okay, let's see. I haven't seen that in a while, but I'm sure I'll be able to explain it to you.
And so it would be this. Our teacher only taught us this way, and he hasn't taught us in all these ways.
Let me see.
But I think I basically understand like the main thing.
So it's just about the valence electrons, right? About the valence electrons.
Yeah.
So the idea is that you link up, for example, you link up these two valence electrons, become a covalent bond.
Oh, it's covalent, it's not ionic?
No, it's covalent. Wait.
Oh.
Yeah, it's covalent bond between these two.
Yeah.
This one is... Yeah, these are molecules. Yeah, these are covalent bonding. Yeah. Ionic is when...
It's like giving out. That's what my teacher said.
Yeah. It's giving to the other one, not sharing a pair of electrons.
Okay. So when we write for the sulfur, do we only write 6, which is the valence electron, or we write all the 16?
Which one? For this one?
Yeah, sulfur.
Yeah, it will be 6. So 1, 2, 3, 4, 5, 6.
Yeah.
So these 6 are for sulfur because that's a valence electron of sulfur.
Okay. So we only write the amount of valence electrons, right?
You mean in this form?
Yeah.
Yeah, so you write 6, but then these 2 electrons belonging to the O here, right? But then they are shared. So these 2 atoms, they share the O and the 4 electrons here. So then these 2 electrons become part of the O, and then these 2 become part of the S. Right? So that's why when you count the electrons, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So that'll be 12 electrons, and this one will be 1, 2, 3, 4, 5, 6, 7, 8 electrons for O here.
Okay.
Yeah. So 8 electrons is a stable one. I think 12 is a stable one. I can't remember. Should be. If it's SO3. Yeah. Then that should be a stable form.
Okay.
Yeah. So that's covalent bonding.
Is chemistry gonna get harder than specialist?
I don't think so. Because okay, the thing with chemistry, right?
Yeah.
If you need help, go to YouTube. I learned everything from about chemistry in YouTube. No problem.
Okay.
Specialist math. The problem with math is that the questions are very different. In chemistry, questions are the same. Like if you look SO3 online, there will be someone explaining SO3.
Oh.
Do you understand?
Yeah.
But you can't find someone to explain like the specific question for specialist that you sent me.
Yeah.
No one will explain that. But you can find so many Lewis dot structure for whatever molecule that you need to find. Most likely someone have explained that before. Okay, all right. Let me go through. Let's see, PSNT structure and tips here.
Will math move to English as well, or stays in?
Hey?
Will math class stay in here, or it moves to like the other location?
Most likely it will stay here. Most likely it will stay here. Yeah. Oh wait, but it's easier for you to go to the other location, right? Go to Trevi.
What time? Is still this time?
It will have to be this time, yeah.
Then it doesn't matter.
Oh, okay, yeah.
It'll be the same because it's just drive to here.
Oh, okay, yeah. That will be here. It will be here.
Okay.
Yeah. All right. Okay, let me go through this. I'll just go through the main keywords. We have read through a few of these. Okay, any question for the first dot point?
First dot point. Is this saying that's bad?
No. Okay, yeah. Let me go through it. Okay. The bolded one is what you need to focus on. Okay, so you can use these keywords here, like English, right? Due to whatever reasons or as a result. The idea is this. The main idea is the difference between documentation and statements, right? So this is good, this is not so good. It's okay, sometimes you have to make statements, but it's not so good.
What's the difference between those two?
That's right. So that's what I want to go through. A statement is like, it's sunny today, right? And you're like, okay, cool statement. A documentation is a statement plus a reason or justification.
Oh, so it'll be like today's sunny because it's like sun.
Yeah, because the clouds are clear, because the sky is clear.
Okay.
Right? So that's a basic one, but in math it will be something like this. Okay, for your example, right? Actually, it's how to say. Okay, a statement would be. Okay, I'm gonna use the bueno bar again. Okay, a statement is going to be 20. Remember, in assignment you can't use I will choose. No, there's no I. Yeah. Have you written an assignment before?
Oh yeah.
Yeah. Okay. So it will be in third person, right? And you have to go. 20 bueno bars will be tested. That's a statement, right? Because I'm like, okay, 20 bueno bars. Why? Why 20? Why not 15? Why not 25?
So I have to say the limit, because it says it's minimum 20.
Yes, that's right. Okay, so you can just say like as long as you give some sort of a reason, and sometimes it's not the reason from the book. So you can not from the task sheet. Sometimes it can be 20 bars of buenos will be chosen, so that the sample size is large enough to represent a good, to have a good representation of the population.
Okay.
Right, I'll say that again. 20 bars of bueno will be chosen so that there will be enough variation to represent the population.
So year 12, I can even say 30 because like What was the name of
Central limit theorem. Yeah,
Central
yeah.
limit theorem?
But you won't do it. You won't have to do it. Because in year 12, you will not be doing an assignment on hypothesis testing. In year 12, most likely your assignment will be on matrices. That's my bet.
Oh.
It will be on matrices.
How?
Because the specialists that I have had so far, they were mostly doing assignments in matrices.
Oh. Okay.
Because in unit 3, right, that's the one that you do the assignment for ATAR.
Yeah.
There are two very interesting matrix concepts or vectors concepts. So it's either matrices or vectors, most likely.
I think I saw something about vector in this term's content.
Yeah, yeah.
Oh, there is.
I think you'll be learning about vectors later in the last three weeks. I think. Let me see. No. Sorry, not vectors. Permutations and combinations, counting methods, and then trigonometry. Unit circle. So no vectors.
Heard of this word something?
Sine, cos, and tangent.
Oh, I think I did that in grade 9, but I can't remember.
There'll be more stuff like the exact angles and stuff, but don't worry about it. We'll get there. Okay, so that's the difference between documentation and statement. The idea is that in your assignment, you want to have more of this thing here. It's like, a quadratic equation, I just explained what it was, that was the x squared thing, was used to model this section because the shape of the section resembles a parabola.
Oh, that's why our teacher told us to like provide reasons.
Yes.
That's what he meant.
That's right. That's the key word here, documentation. Okay? Brings me to this thing. If you are looking at this one, you have to look at the task sheet. I'm pretty sure Julia will mention this to you later. Okay. See the difference? Mark 3 to 4 is documentation of appropriate assumptions. You only get 1 to 2 if you have statements of assumptions, not documentation.
So we have to write why we make that assumption?
Yes, you have to write why you make that assumptions. Good, very good, yeah? So you see keywords again, accurate, and then documentation of relevant observations. So you got to write observation that is accurate, and it's a documentation, which means you have to say why you're including the observation. Okay? And then accurate translation of all aspects, and define okay, this is different. This is the mathematical concept. Okay?
I don't know why, but I never get the mark for English. I never got in the past 3.
You mean like the last bit here, the communicate part?
Yeah. I don't know why, but I always get like 1 or 0.
Can you send me a past assignment? Later, not now.
Sure.
Yeah? Just email me your past assignment. I'll have a look. Because most of the time, my student is here. Okay? Not the one that they will mess up the most is this one here, evaluate, verify. This one is where they lose most of the marks. They'll get like 3 here, and then sometimes you will get like a 5 here instead of a 7 for the solve part.
How do I send files on Discord? I thought you sent. I thought I sent at the right place, but it was in general. I've got no idea.
You just need to go to like James Specialist, press on the plus button here, and then you go file, and then you select whatever file.
Oh, okay.
Yeah. So you have to go to the channel first, and then next to the messages, normally there's a button for add files or upload files or whatever. Yeah, but it must be in the main channel first.
Okay, can you like delete or withdraw the thing I sent in general? I don't know why I can't see it anymore.
Yeah, I don't know why either. Wait, did you send it to me on?
I think I sent it in general.
Yeah, I thought it would be there. I mean, I clicked on it. I could download it. Yeah, it should be on general, right? But yeah, I don't know why. It's gone now. It's weird. Either Julia deleted it or maybe I accidentally deleted it. I'm not sure. It's fine. It's gone. Don't worry about it. Okay. So yeah, so that's the documentation and statement things. Okay. Moving on. The next part is Yes, spelling and grammar error. These are the key here. You can use Grammarly or Quillbot. Okay. If you don't know how to use Grammarly, Julia uses Grammarly a lot to double check on stuff.
Oh, I can't use Grammarly on my laptop. It got locked.
Got locked?
Yeah, it got locked. I don't know why.
Then you might have to go to Quillbot, copy paste. Or you can just use your basic Microsoft Word. It will have like if you have any spelling error, it will show in there.
Oh, so that's what it's checking. What is?
Yeah. When you see like the red stuff, normally there's like an error. If it's blue, there's normally a grammatical error. It's that you say he are instead of he is, then it will mark that. But it's basic stuff only. The thing is, when you do your assignment, right? Send me different version. When you start working on your assignment, I want the first draft done in the first week. I'm sure you can do that. So first draft is dot points.
What?
Dot points only.
In dot points?
Correct.
Oh,
not full sentences.
Oh, I basically just did like my full assignment for the draft.
I want something even like more straightforward than that. Okay, I'll get to that in a second. The reason why I want dot point is similar to this. You see how like these are all dot points? It's easier to follow. Right? When you're sending me your assignment, I want to see, and I'm pretty sure Julia will mention this to you. When you're planning something, you have to start in dot points. Right? The dot points can be simple statements or full sentences, right? It doesn't really matter much, but the idea is that when you're using dot points, you're not worried too much about organizing your thoughts, right? It's just dot point. Oh yeah, gotta talk about this, gotta talk about that. I'll get to that in a second. Okay. I think I'll mention about the whole draft things a little bit later. Okay, so no spelling grammar error. Use Quillbot, and then so make sure you always use the symbol. Okay, the proper symbol in Microsoft Word, not the star. All right, so use the proper symbol. Yeah. And then word limit stated at the end. Right, before I continue, this is called the final checklist, not the beginning checklist, because you can't actually. I put it at the beginning, right? Because you have to keep everything, all of these points in mind, all the red points in mind, while doing your assignment. Oh. But you can't tick them off until your assignment is done. Right? Like, how can you know that there's no spelling grammar error until you have finished everything? Right? So that's why it's called a final checklist. So you keep that at the very end, right before your submission, or like right before you send me your final draft. You go through all of this. Okay, have I made sure I have documented everything, not just stating, and then have a check for all spelling and grammar, have a check for all these mathematical symbols, right? And then you can start ticking things off at the very end. But you need to know about this as you are working through it. Right. Next is all graphs and image are labeled and referenced. So labels may have to be above tables but below figures and graphs. Now, this is something that is very specific. Okay. This is my own personal preference. But this is actually because of university requirements. Right? I did engineering at University of Queensland. They were very strict with some courses. They are very strict with these labeling and references, and that's how I learned about these referencing. And it makes so much sense. Like when you do it, it makes sense. So labels are above tables. Why? Above tables because when you read a table, you read top to bottom, right?
Yeah.
Right. You read like some sort of labels here, and then you read labels here, and then you read a number.
Oh, with a graph, you like read the labels at the axis first.
Not quite. So not for the axis, but in general, if you have if you have like a figures with some sort of drawings, that's an image, or a figure which is like a graph here, right? Yeah. Right. You look at the whole thing. There's no top to bottom, right? Or you also look at the whole thing here. Your eye will just be like that, right? Or your eyes will just be like your movement will be like, oh yeah, that's axis, that there. So it looks over the place. As opposed to a table, you normally read like that, and then you read down here, and then you read around here. Okay? Because it starts from top to bottom, the table will be labeled on top, table whatever, X, table 1, table 2. Okay? But the figures, you would go figure Y at the bottom here. And you have to write the names, whatever. Right? You have to label the figure.
Oh, my teacher have never told me about this before.
That's why I said this is very specific. Okay, this is very specific instruction. You see in good assignments, it looks very neat because they do exactly that. Now, I'll show you an exemplar assignment, 20 out of 20, or 19 out of 20, this one here. This is unit 1. Yeah, so this one is actually Math Specialist, unit 1. Okay, so note how he labels. See, tables on top, right? Table labels on top, and then figure labels at the bottom. Figure 1 draw data. Okay, looks neat, right? Technically, I would center this, not left aligned. I would center this. The table would be left aligned because again, you read left to right. Right, the table label will be left aligned, but the figure label is normally center aligned. Some university courses they will even check on that.
Oh.
Yeah, like because they actually mark you because they will state that in the instructions. Like make sure table because I did a course on like report writing. That's why it was so strict because it was specifically about report writing, like writing reports, and they're like figure labels in the middle, because they scan the figure is in the center. Okay, so yeah, so this is an example of that. And then the next part is reference. You need to mention about the table and figure first before you show it. So many assignments I've seen, they just be like, imagine this assignment, right? But instead of showing the these are the obvious one, but they just show you this table, like without any explanation. They'll be like, oh, table 3, the mathematical formulas used to solve and create piecewise function for tasks. At first you'll be like, sounds about right. I mean, that's math content, that's part of the assignment, but that's not good enough. That's not good enough. Why? Because you are telling the reader of your assignment to have to think about what this table is for. Right? Like the title doesn't say enough things. It doesn't explain enough. Now, if you read the top part, mathematical. So read from here, mathematical formula to model the traffic. For this thing, a variety of transformations. So basically, this assignment is about modeling the traffic. So he gets the traffic data, and he needs to create functions, right? So for each part of it to model the traffic, okay? So a variety of transformation and regression techniques will be used. Transformation techniques will be shown through a variety of piecewise functions and yada yada. Sorry. So talk about transformation functions, right? And then at the end, the transformation functions that will be used. You see, this actually is a mistake there. You can't use apostrophes. You can't use short form. You have to be that will be used. In the report, you can't go thou. Or like you can't go he's. No, you have to be he is. Or like that is. Okay? So that's one thing that I would pick up on. Okay? But most teachers will be like, oh yeah, that will be used. Yeah, that makes sense. No. That one, you do that in university. Red circle, drop 1 mark for communication. For report writing, that's strict. Anyway, that will be used. Have the explanations documented in table 3. So if I read from top, methodology, mathematical formula, read blah 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 blah, and at this point, the transformation functions are documented in table 3. I'm like, that's what I'm looking for. I'm looking for a table 3 where the functions will be explained, and then bam, table 3 is there. You see? So see how like this one makes logical sense, right? You need to introduce something first. And then you show it, okay? Like imagine if you don't explain it first, it's like me throwing you that piece of paper. Was it easy to follow? No, it wasn't, right? So that actually also illustrates the point for this one here. You need to talk about what is it that you want to show before you show it, okay? I don't think any high school teacher or not many high school teacher will mention this to you, okay? This is something very specific that only someone who has. That's why this is the funny thing. But like most high school teachers, they don't know about this because they don't have a chance to. They learn about teaching at school. They don't learn engineering at university. Does that make sense? Yeah. I learned engineering and I'm teaching. That's why I know all this stuff. It's from engineering. It's not from teaching. Yeah. So that's why it makes sense. Sometimes it's like, it makes sense, but why? This is why. So that's why you need to introduce the table and figure. Okay? Mention that first. Something as simple as the calculations for this section are shown in table 4. Or for you, be like the theories about hypothesis testing and confidence interval, or the formulas for hypothesis testing and confidence intervals are shown in table 3. And then you go table 3, blah, 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 and then you show table 3. Okay? So it flows. And another reason for that is when someone is reading your assignment, remember reading your assignment, they read the text. All right? The figures and tables are only there to support what you are saying in the text. So the paragraphs are more important. Are the things that I read first before they see the other stuff. Okay? All right? No tables should go over 2 pages. Some teachers will be okay with it. I'm not okay with it. Okay? I'd rather you have to rearrange your content so that the tables are fit in 1 page. So you see this assignment, right? The text, okay, go into 2 pages, right? That's okay. But the table has to be in 1 page, right? And then this solve here, see, okay, that one actually get chopped off because of me exporting it. But originally the figure is in 1 page, right? I just exported it. There's some issue with it. But yeah, so you see this one, this table go over 2 pages. I would normally not allow this.
How do you fix it? Do you just leave it blank and then just move it to the next page?
Yeah, so you have to split into 2 tables. Okay. Yeah, or you have to arrange your content around. Again, that's about organization of your assignment. Okay, and we'll come to that a little bit later, towards the end when you have an assignment. But ideally, no tables go over 2 pages. So check your mathematical terms and expressions. Check your font size and colors. Now this thing here. Have you used this before? The normal heading 1, heading 2. You will need to use that styling in your Microsoft Word. I don't have Microsoft Word on this one here, but the idea is that like the styles option. Okay, look. I think when you start working on your assignment, bring your laptop next lesson. I'll go through a few key points before I go through the content. But I'll go through a few key techniques, including this one here. Okay, so you can see that. So that's what I'm saying. Like the first draft is just dot points only. So I care only about the ideas. The ideas that what you're going to write about. What numbers are you going to use? What are your calculations? Are your calculations correct? Right? And then once everything is good, then you start putting them into full sentences. Or like connect the sentences to make it a full assignment.
So the draft I submit to the teacher, do I still keep it as...
No. What were you saying?
For the draft, do I keep it as the dot points if I send it to the teacher?
No. For the teacher, you have to send the full one.
Oh.
Okay? So, so for drafting, right? For the process of drafting, let's say if this is 0 and this is 1 week, right? 1 week, 2 weeks, and I think you got how many weeks on this one?
4 weeks in total.
4 weeks, right? Normally, this is school draft.
Yeah, it is.
Right? And that's why I'm saying this is Koi's first draft.
Oh, so it'll be like next month. Yeah, I'll just show you next Wednesday.
Yeah, you have to show me next Wednesday. Within 1 week, I want most of the content to be there. But that's why. Sorry?
Okay.
Yeah, so if your teacher confirms the assignment this week, over the weekend, you gotta go and buy whatever you wanna buy, measure, and start putting them in tables, do calculations, because you can already do calculations. Right? You know how to do hypothesis testing and confidence interval. Just do it. Start putting the values in your assignment and start typing out what are some assumptions, what are some observations, yada yada. Okay, start typing them out. You don't need to have it complete, but I want to see what ideas you've got so far.
So I can just list out all my ideas. Okay.
Yeah, just list out as many as you can, right? That's why this is the technique from engineering. The first draft, the school draft, they call it the first draft, but that's wrong. That's actually not what the first draft should be. The first draft should be very drafty.
Oh, so it's just not even paragraph?
Not even paragraph, no. Okay? Because you're just putting down all your ideas. To me, that's kind of like you're putting out whatever you can think of so far. That's like brainstorming. When you're brainstorming, you don't really organize things. Because if you start organizing, you will slow down the process and you can't put your thoughts down fast enough. You start losing your thoughts. Okay? So whatever you can think of, just put it down. Right? Worst case scenario, I cross it out. Oh, wrong assumption. No problem. Right? You'd rather have 5 assumptions and cross out 2 than writing 2 of them very well and they're both wrong. Does that make sense? Yeah. So just and then when I see it, I can be like, good, no good, no good. And then whatever that's good, then you can flesh out, write full, beautiful sentences. Okay. Make sense?
Yeah.
So that's the idea. So that's my first draft for assignment. Right? It's not the same as a school one.
This code on my laptop either. So how am I going to send the file?
You can access your Discord on browser. You don't need to have an app.
Yeah, but on browser also doesn't work.
Because the school.
Yeah, the school.
Email.
Email?
Yeah, email me the
Oh,
draft.
so the ATA Academy thing?
Yeah, it's the admin at ATA.academy. Send it to this one.
Okay. I think I've contacted that email before.
Yeah. So just send the draft to this email. Okay.
Yeah.
So that's before your school draft. By the time you get your school draft, your draft will be like basically pretty good. Yeah. And the final draft will be even better. That's how you get your 20 out of 20.
One of my friend, he got full mark for his draft. So you know like how there's a checklist? He got those things all completed.
Yeah, you can. Yeah. Most likely he has a tutor. That's my bet.
Uh,
Does he?
Not sure. He
Not sure.
he left in grade 8.
Oh, okay.
Yeah, he went to something called like Ipswich School. It was pretty bad.
Oh, okay.
Yeah, I don't know.
Yeah. It's unfortunate. It's okay. But if he's good, he will be okay in that environment. Okay. Okay, there is a little bit of an issue here. So this one, technically, it should be the fancy FX here. Not this font here. So the idea is that when you're using equations in paragraph, right?
You have to whatever the alt plus equal sign.
Yeah, that's right. Alt plus equal. Good.
Yeah. To get it like the actual
Mathematical font.
Yeah,
The math font. Yeah.
Okay.
Yeah. So you get the idea. Okay. No acronyms. You can't say substitute. You have to go. Sorry. You have to go substitute. You can't say sub. Right. Full terms. Yeah. Full sentences. Full words.
Yeah.
Anything that's plural, like assumptions, observations, strengths, and limitations, at least 3. That's what I'm saying. Like when you're brainstorming, you gotta brainstorm as many as you can.
If I list more, will it be better or
Better, yes.
better?
Yeah. But of course, if you list more and some are wrong, that's not good. But that's why I will read it and I will tell you which one you need to. That's not good. Cross it out. Okay. And sometimes your assumption might actually be an observation instead. So I'll get to that a bit later.
Yeah.
Okay. So and everything that you need in the criteria sheet will have to be in the report, right? Not in the appendix. All right.
What is the appendix? I've never used it before, but my teacher explained it. I didn't understand.
Okay. Did your teacher try to explain the appendix?
He told me like put the equations in or something.
No.
Like the repeated equations or something.
Yes, that's right. That's right. Okay. It's like this. Remember how I went through the factor theorem, right?
Yeah.
And the steps is just sub a number in and then long division. Those 2 steps, right?
Yeah.
You would want to show those 2 steps once, at least once in the main part of your body. But imagine if you have to do that 3 more times. I don't want to see it again. You already showed me that you can do factor theorem, for example, right? Let's say hypothesis testing, right? You already showed me that you did hypothesis testing once already, right? If you were to do it again later, I don't care.
If it was like other values, do I still put it in the appendix?
If it's the first time you're calculating something, no, you have to put it in the main body.
Okay, so second time, even with different numbers and different values, I still put it in the appendix.
Yeah.
How do I put it in the appendix?
Okay. Example.
I thought you just write appendix and then you just do the thing.
Here. Appendix. So this is the equation. So he showed like how he this is how. So basically, you need to create that equation there, the quadratics here, right?
Yeah.
And this is the mathematical behind that, but he already showed this once before, right? So and after that, instead of saying, actually, we'll go through that one here. So the appendix, right? Okay, let's say you would go show hypothesis testing and confidence interval math, right? And then after that, you would just say hypothesis testing and confidence interval. Let's say hypothesis testing is applied similar to section. Let's say this is in section 1.2, for example, right? We start with 1.2. It's applied similar to section 1.2. Okay? This is not grammatically correct, okay? But the idea is that you say it's similar to section 1.2, and the results as you're going to introduce in, so normally you introduce them in the table, right, in table 4, and then here will be table 4, and then you show the results of the calculations only. You don't actually show the calculation itself, okay? But you can mention here calculations, detailed calculations are in appendix B.
So in the main thing, do we just write the answer straight away?
For repeated calculation, yes.
Are they gonna read the appendix if we
No.
like? Oh no.
Most of the time, no. They will skim through it. So for me, I would be like, okay, so this is the appendix showing calculation of quadratic. Yeah, looks good. Move on. Right? Like, oh, this appendix is to show the calculation. Yeah, that's the same thing. Yeah, linear. Yep, that's the same thing. Yep, same thing. Yeah, okay, good enough. Yeah. So as a teacher, I will not check everything. Teachers are humans. They have time bounds, limits. They will have like maximum, I don't know, half an hour, maybe an hour per assignment to mark. I don't think they spend more than that. If anything, they spend less than that to mark your assignment.
Oh,
most likely.
My science teacher forgot to mark my assignment and she marked it under 2 minutes.
Yeah, I know. That's bad. They're supposed to spend a bit more time on it. But anyway, so you see, if they have 10 minutes, they're not going to read this. Right? They might skim through it, be like, oh, okay, let's see, appendix, okay, figure 16, yeah, good enough. Right, they'll go back to the assignment. Okay, so, but the idea is that you need to write your assignment in a way that if the head of math, okay, put it this way, when the assignment for Unit 3 is submitted, right?
Unit 3?
Yeah, Unit 3, like the one that counts towards ATAR. QCAA, right? The Education Organization of Queensland will come and pick randomly some assignments from your school and check the marking. If they think the marking is too easy, they will tell your school to push up everyone. If they think it's too hard, too easy, it will push down everyone, my bad. If it's too hard, they will push up everyone. Okay. Alright, that's moderation.
Everyone?
Almost everyone, yeah. No, but they will pick a random sample. See, it's sampling again, right? They do hypothesis testing. What are the chances that I pick like 3 out of 200 people or like 20 papers out of 200 and they all look so easy, right? What are the chances of that? So that's why they also do hypothesis testing.
Okay, if I get like a really bad teacher in like grade 11 or 12, can I change classes?
Depends on the school, but I don't think so.
Oh.
But at the same time, it doesn't matter.
Doesn't matter?
It doesn't matter. It doesn't matter because the one marking your assignment and your exam is most likely not your teacher.
Yeah, but sometimes like some of the teachers don't really teach.
Oh. Yeah. You can try to change class, but depending on your subject selection, you may have clashes between subjects. Oh. Yeah, that's the thing. Okay. Yeah, but don't worry. I think for you, right? Even if the teacher is bad, as long as the teacher doesn't like annoy you, you can still learn the content yourself. Because I'm pretty sure for specialists, I will be able to get you always ahead of school. And methods, you can still ask me some questions on methods on the chat. Because I don't think you have much trouble with methods, I'll be honest. I don't think you have too much trouble with it. Maybe in Unit 2, there are some parts that are a little bit tricky, right? But we'll get there. We'll see how you go when we get there. Yeah, because the thing with method is if you want, at that point, I can always put you together with, I think I have a few more students in year 10 at the moment. Yeah, to study methods together. Specialists, we'll still do one-on-one, but methods in the group is okay.
But methods, are they good? Are they good at math?
Yeah, they're pretty good, yeah. But of course, I will only put you with students who will not hold you down, if it makes sense. Yeah, they will not be like slow students. So we'll when we get there, we'll know. Okay, so that's what the appendix is for. Okay, for repeated calculations. All right. So appendix is for repeated calculations. Okay. Next. Okay, now we'll actually get to the main content now. So that was the general checklist. Now is the main content. Introduction. Write this one last. Don't start with the introduction, please.
What?
Because the difference is this. The introduction has to introduce everything you will do later.
Oh.
How do you know what you're going to do later until you have done everything?
Oh, yeah, sure. And sometimes at the start of like an assignment, you don't even really know what you're doing.
Exactly. Why do you write introduction first? No, don't write the introduction first. You go straight to formulate.
What is Oh.
Oh, that's just
observations and assumptions. Okay.
yeah, observation and assumptions and mathematical concepts.
So it's like what equation you're gonna use, like.
Yep. What concept? So for you, it's hypothesis testing and confidence interval.
So I need to introduce all the equations and stuff.
Yep, in the formulate section. Well, it depends on what your school will give you as a scaffolding. It may not. It may have a different label. It's basically formulate. There are only three main important things in here. Assumptions.
I think it's exactly the same thing.
Should be. This is quite standard. Assumptions, observations, and math concept and techniques. Math concepts and techniques. These are the three things they're looking for in the formula.
Why don't you explain why we use the concepts?
Yes, of course. Yeah. But you only need to briefly introduce it. You don't need to go into too much detail. And when you're introducing the concepts, okay, I'll show you.
Is the math context the method?
No. The but the method, yes, that's the method, not the solve. Yeah.
Okay.
Yeah. So you see, linear equation, function explanation, m is the gradient, c is the y-intercept. Yeah. That's it. All right. And just mention that I think it was mentioned. He mentioned it here that regression models and techniques will be used to represent the line of best fit. Blah blah blah. Calculate this, calculate that. Yeah, and then some will be transformation will be used to find a better model, yada yada.
I think we went through line of best fit briefly for methods at the start of the term or at the end of last term.
Okay, because you need to use it for your assignment most likely later.
Okay.
So yeah, so you see, this is the idea of how you introduce the concept. You don't actually put numbers in there.
Oh.
Right? You just put formulas and you explain what it is to show that you're understanding the formula. If you have space, which I doubt you will, if you have space, you can use an example. But don't do that first because the best example is your own calculation later on in the solve part.
Solve, okay.
Yeah, because in solve, you have to use it and punch in some numbers and show the table with the calculations like that one there. Right? So normally there's no point showing examples for the concepts. Okay, so that's what they're looking for mathematical concepts. I'll show you this guys, and I'll send you this assignment later. Okay, so see, he actually split the observations into two columns. Observations, and this one is explaining and reasoning. Right, observations. There is no data for previous years. Reasoning. The accurate is only for 2021, but in 2022 there could be a significant change to the traffic and traffic flow, which would affect the accuracy of the model. Yeah. But you can write them in one sentence. Yeah, so I've seen some students do like observation in one table and then sentences, but this is just make it clear that I am showing you the reasoning. You better give me the marks, okay? Because that's what the criteria sheet is about, right? The criteria sheet for formulate is just are you giving documentation, right? And are you giving documentation of this one here, and are you doing the actual are you identifying all the mathematical concepts and techniques correctly? Right, so accurate translation of aspects of the problem by identifying mathematical concepts and techniques. Yeah. So again, this is the part that every student will be a little bit different. Okay, but yeah, you need to look at the formula sheet and look at the highest marks and look at the keywords in the criteria sheet. Okay, so for solve, it will be accurate use of complex procedures, right? And you need a valid solution. So basically it's saying that your calculation must be correct. So solve, I think for you should be aiming for 7. Like you shouldn't be losing any marks in solve. Like all your calculation has to be correct. Right? Now this one is a hard one. Discerning applications of mathematical concepts and techniques. So basically they're saying that for you need to understand hypothesis testing really well. And you need to understand confidence interval really well. Like the thing I said earlier, like 95% CI is the idea that when you 95% of all the confidence intervals you calculate will contain the mean. But which 95% we don't know.
According to the way my specialist teacher teaches it, I understood nothing about those two things. Like nothing. Yeah, she just told us to like punch those numbers in, and that's all.
Yeah, that's what most teachers would do. Yeah. Again, as I said, I know these things because I'm an engineer. Right? A normal teacher is a teacher's teacher. Is not they don't have any other training apart from teaching. That's their disadvantage. Anyway, so yeah, accurate and appropriate use of technology.
Technology. What do we need to use for technology?
Excel for the tables.
We need the
Oh, I guess you can just use your word tables.
We need to create tables for this?
Yes, you need to show the data, and then you need to show the.
I thought you meant like those graphs. Yeah.
Yeah. I think you might need to use the graph. Okay, look, you might need to show. You might want to show. Yeah, I'm not sure. I'm not sure yet. I don't want to say too much because your teacher may or may not use the things I'm gonna say, like the box plot, the bar graph. I don't know what is it that they will mention. So just see what they mention for technology section, because each school they want something different depending on the assignment. Okay, the concept is easy, but the technology, just see what your teacher is going to tell you about. Okay, evaluate, verify. We'll come back to that later. So let's go back to this one here. So that's what formulate is. Now these ones, yeah, so as I said, they should be documented under 2 separate headings if you can. Okay, but yeah, so you need to add onto them later. So the idea is that you will start working on your assignment, right? And then you would think of a few assumptions. You'll be like, oh, I'm assuming that follow normal distribution. Observation, there's a batch number in the back, for example, because you're going to talk about it later. All right, so there's a batch number in the back, and yeah, there's a lot of information. There's like the serving size, there's the calorie, whatever. But note that sometimes the observation, you may see something, but it might not be something that you need later on. And if you don't need it later, cross it out later. Right? But stay as many as you can, because you can always delete.
Yeah.
Right? I can have you delete, but I can't really tell you what to write more, because then that means I'm feeding you ideas for your assignment.
Yeah, that's actually just like you writing.
Yeah. Okay. So yeah, I can give you hints and stuff like that, but if you write more, I can be like, oh, this is not really a good idea because whatever.
Do you think the school has a way to check whether you copied it from ChatGPT or not?
Yes. There's something called no GPT or something, but the thing is, that's not accurate. Okay, so you can use ChatGPT to give you some ideas, but don't copy paste. Yeah. Okay, you can read ChatGPT. The best way is to read it. Oh yeah, that's a good idea. Put it aside and then type it again yourself. So it will be different. Yeah, but Julia actually has written a few. I think she might mention this to you, but she's written a few like example assignment, and when she put it into ChatGPT, it said 50%, even though she wrote the entire thing herself. It's just because her writing is so accurate that it thinks it's a chatbot who wrote it. Yeah, so that's why it's not accurate. That tool is not accurate, so don't worry about it. But ultimately, you don't use ChatGPT, don't copy paste. Yeah, because that's plagiarizing from ChatGPT. Okay, so this one here, the observation and research must be relevant to the model. So it must be relevant. You will need to write as many as you can. Later on, I'll tell you if there's anything that's not relevant. I'll tell you it's not relevant, and I'll tell you why. Okay, but again, first draft, dot point, write as many things as you can.
But I have to write the solve part in like the.
Yeah. Look, the dot point again. The dot point is a general strategy. Okay, if you are so confident, you can write that in paragraphs, but I don't want to see like a massive paragraph, because that a massive paragraph at the early stage, normally you need to rewrite the whole thing later. Like almost always, because almost always either one, you don't have enough word count. You have to add something to your method. 2, you have too much word count. You can't talk too much about something too random. Cut it out. So that's why I don't want big paragraphs at the beginning. Okay, so by big paragraphs, I mean something like that. Like this paragraph can consider like quite big. 6 lines is okay, not too big. I've seen bigger paragraphs. I'm like, don't want to see that at the beginning. So these are all small ones. This is a good example. Oh, here. This is the big one. I don't want to see this in the first draft. Because normally when I see this in the first draft, like for me, like the 1 week draft, yeah, the school draft you will need to write in paragraphs, right? But for me, if I see this, I'm like, you just brain dump. But rather instead of brain dump in dot points, so I can see clearly what the points are. You're trying to link everything together. But normally early on, it's very hard to write perfect assignments, right? It's almost unless you've written like 10 of them, you can't write a perfect assignment from the get go. It's not something that you like a student normally can do straight away. So
my science report, I wrote 1 paragraph for the whole page.
Yeah, that's not good. That's definitely not good. Okay, that's bad communication actually. Okay, so yeah, reason, justification. Yeah, I went through that earlier. Concepts. Yep, introduce and explain the parameters. What I said earlier, right? M is the gradient, C is the y-intercept. For you, it would be like the z value is whatever, and then the mu h is whatever.
Right. And for our school, they write the z value as for what?
T something, T alpha, right?
T alpha, and for 2-tailed test they write it as T
Alpha over 2.
over 2. Can I still write it as Z?
Most likely no.
Oh, so
Use the school one. Yeah. Just write T alpha over 2 and explain, T alpha over 2 is the value on the net standard normal distribution for the 2-tailed test, because the 2 areas, if it's for example 95%, will be 2.5% on each tail. Like that.
That's hypothesis testing, right?
Yeah.
That's not. I'm confused about like what I've learned. Can't remember.
The hypothesis testing?
I only know how to do it, but I can't remember like what I learned.
Okay.
So next time I might even forget like what I learned last time, but I can still do it.
Yeah. Look, that's why watch the recording for last week, because last week I explained the hypothesis testing. Yeah. So go to that section and watch that again. It might make more sense. Okay. I'm recording this week as well, so if you need to go back, you can always go back to these later. Okay. Yep. Now solve part. I think this one is quite straightforward. Make sure you explain the types of calculation, right? So explain in the paragraph above that, and then you show the steps. So for example, here, it's like, to use a model to blah, 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 you need to determine the model, displacement, velocity, yada, yada, and then you show it. So it's like, in your case, it will be like, in order to test the hypothesis, the significance level is at 95% significance level. Then the T alpha will need to be used, or like you mentioned, it will be a 2-tailed test, because the value that's going to be tested is mean is exactly equals to, so it will be a 2-tailed test, and so T alpha over 2 will be used. I think, yeah, T alpha over 2 will be used in the hypothesis testing formula. So you say all of that, and then you show the calculations.
Okay.
Yeah, so you need to explain the steps in English first, and then you can show the mathematical steps.
Well, I think that's why I don't have like any marks for communication.
That's right, because it's just chucked in the calculation and you don't say anything about it. Yeah. So that's now you know. Remember, your math assignment is about the text. It's called an assignment because it's about the text. If they want to see just calculation, you better off doing the exam. Okay? Yeah. So they focus more on the text, not on the calculation so much. The calculation is just to make sure, okay, yeah, James have completed the calculation that he can do hypothesis testing, he can do confidence interval, check the numbers, yep, calculation is correct, okay, assume all the numbers are correct. Now let's read the text. Does he have documentation? Does he have justification for assumption and observations? Do the observation and the assumption, are they relevant to the task? Has he documented the limitations and strength? You see, this is all text. Yeah, so that's why.
Yeah, but what is the point of assignments? It's math. Shouldn't it be all exams?
Good point. The reason for why you need to write math assignment is because it's about communicating. You're communicating, you're problem solving, right?
Yeah.
But this is when you're solving a big problem, like hypothesis testing. It's not done in one page, right? You have to show where you get the data from, how you got the data, what you did with the data, what are the concepts behind it. Sounds familiar?
Yeah.
That's all of the formulate part. And then show actually how you apply all the concepts to do the data. Because put it this way, let's say I'm like a CEO, you're working for a company and I'm like the manager of the team, right? And you're testing the products for like Kinder Bueno, right? Working for Kinder. Right? I don't want to see a bunch of calculations. Yeah, I'm gonna assume that because I'm hiring you as an engineer, you can do your calculations. I may check a few things, right? Maybe I'll get a peer or your friend to check your calculations. But what I want to see is the writing. I want to see what you actually did for the testing to see if the testing makes sense. And I want to read the results. That's why there's a conclusion, right? And also want to read the evaluation to see if maybe your method you can actually realize your method is actually not so good, and I can't really present that to the CEO because otherwise I'm gonna get fired, right? So that's why in real life, the calculations is only like secondary to the results.
Does this say the weight or something? It only 6 pages, but it can't go wrong, right?
The paper is 55 GSM, grams per square meter, but it's quite hard to test that.
Yeah.
It's really light, so it's a bit hard to test that. Like 55 grams per square meter, like you need a whole square meter of paper to test that.
Yeah.
But if you weigh only one page, it's it's going to be a bit harder. That's why I think the easiest one is food. Find some cheap food items and test them.
I might need to buy like 25 because I might eat some before I even start the assignment.
Hey? Yeah, so the idea is that maybe when you buy food, you can just measure them, record them somewhere, and then eat them after. You know? Yeah. It's okay. Okay, so yes. Now, this is not applicable to you, so don't worry about the real world exam assignment. That's not what you're going through. So don't worry about that. Don't worry about this one either. Okay. Evaluate, do it later. Okay. So for now, the 3 sections I want you to focus on is solve. All right. By next week, get some of this. Actually finish that one and 2 sections. Sorry, formulate and solve.
So I don't need to worry about evaluate yet.
Sorry.
I don't need to worry about evaluation yet.
You don't need to worry about that yet. But if you can write something, it will be good. So put it this way. Formulate and solve is #1 priority. Right. Both of them are #1 priority for this week. Evaluate. Get some in there because it's just limitation and strength. But normally, until you have completed all the other stuff, you can't really evaluate. So whatever you think, just put in dot points. So evaluate definitely dot points. Solve and the other one, if you want, you can put some small paragraph. It's okay.
Yeah. Okay.
Okay, make sense?
Yeah.
Okay, I'll send you this later. Yeah, let me just I'll pause the recording here.